Hello, this is Jishan Chowdhury from JC Tuition. Today we're going to be talking about the mole and amount of substance. I remember when I was doing my A level in chemistry, no one in my class really understood what the mole was. So I think it's just a really important concept to understand because it's just used in so many calculations, and it's just physically how we measure amount of substance in chemistry. So if I asked you how many donuts are in this box, you might say, oh, well, there's 12 donuts. Okay. Is there a quicker way to say it? If I gave you now four boxes, yeah, maybe you could do 4 times 12 in your head. How if I gave you 10 boxes? You might just say, actually, we know that 12 is, you have a word for it, don't we? Say dozen. So if I gave you 5 boxes, you'd say you have 5 dozen donuts. And that is basically what the mole is. It's a way of just when we're dealing with large numbers, um, simplifying it in a way we can all understand and replicate and use. Um, Obviously, chemists don't work with box donuts, they work with atoms at the atomic scale, where there could be trillions of trillions of trillions. So it's really important so that we don't end up writing these really long numbers and making calculations really tedious and long, that we have a word, a standard that we can use to do our calculations and simplify things, and that is what the mole is. Chemists use a quantity which is amount of substance to count the number of particles in a substance, and we measure it in a unit called the mole. And normally it's just abbreviated in units of mole, just MOL. Just knock the E off. And 1 mole is the amount of substance that contains this many particles, this huge number. So that's 6.02 times 10 to the power of 23. And we call this Avogadro's constant. So if you had a mole of donuts, well, you'd have a really upset tummy, as you can imagine, if you had this many donuts. It just seemed like a really weird number. In fact, I'll write it up here again. So yeah, it might just seem like a really strange number to choose, but it's all linked to this guy over here, carbon 12. And it's linked to the mass of carbon 12, which we can see the relative atomic mass is 12. Yeah? And carbon 12 is basically used as a standard for all the relative atomic masses. Everything's relative to carbon 12. So what we're saying is 12 grams of carbon contains 6.02 times 10 to the 23 atoms. Right? So that is basically how we came up with that number. And because we know all the masses are relative to carbon 12, we can very easily find the mass of 1 mole of any element on this table. So we know 1 mole of carbon atoms has a mass of 12 grams. How about 1 mole of hydrogen? Well, it has relative atomic mass of 1 gram. So 1 mole of hydrogen atoms has a mass of 1 gram. How about magnesium over here? Well, 1 mole of magnesium has a mass of 24 grams. Iron, well, 1 mole of iron has 56 grams. So if you have a sample of any element and you know its mass, you know you can have a way of finding out how many atoms it has, which is really important because we can't see atoms. So we need a way to just measure it if we just know the mass, which is something we can measure. It's being a bit pixelated, but bear with me. So this is carbon in the top left here, and we said it has 12 grams. Yep, so that's carbon. Let's write C. What else are we talking about? We've also talked about iron, which we said has 56 grams. We also talked about magnesium, which we said had 24 grams. All of these substances, we can ignore the other two. I don't know what they are, but all of these substances have the same number of atoms, but their masses are different. Okay, they have the same number of atoms, but their masses are different. So I know I've been showing you standard form, but let's just expand it out. This is how big 1 mole is. So having 1 dozen of donuts is still a lot, but imagine having 1 mole of donuts. It's so much compared to just a trillion, which we all know is a huge, unfathomable number. This is how much 1 mole is. In fact, I read somewhere that if we had this many pennies, let's put P here. If we had this many pennies, so 6.02 times 10 to 23 pennies, and we share them evenly between all humans on Earth, every person could spend 1 million every hour for their whole life. So it's just an astonishingly large number, and that's why we need to put it in standard form. I just wanted to make clear that amount of substance or moles can refer to really anything, just not just atoms. So when you are working in moles, which you will be often doing, it's important to use the unambiguous name. So 1 mole of hydrogen, we're referring to 1 mole of hydrogen atoms here. Yeah, but you can also have 1 mole of hydrogen molecules, so we're referring to 1 mole of hydrogen molecules. It's important to state that. So I'm going to talk about molar mass. So we already talked about the molar mass of carbon-12. Well, we know carbon, so we can just write M. Carbon is 12 grams. We can see that, yeah. But sometimes we're not just working out the molar mass of elements. You might be working out the molar mass of molecules. So let's say nitrogen dioxide. Well, we've got nitrogen, which is 14 grams, and we've got 2 oxygen molecules, which are 16 grams each. That's 32. So 14 plus 32 is 46 grams. And let's say the molar mass of sodium carbonate, so Na2CO3. So again, you just look at your periodic table, find sodium, so that's 2 lots of 23 plus 1 carbon times 3, so that's 32, 48. So that's 106 grams. And actually the unit, and what molar mass is telling us is the mass in 1 mole of a substance. So actually the units are grams per mole. It's not just the mass of what we're measuring, it's per mole. And that's what molar mass means. Molar. The amount of substance and the molar mass, and actually physically the mass of what we're measuring. It gives us a pretty convenient way of finding out any of these quantities. So there's a formula which links all 3 of them. So we've got amount of substance, I'll just write amount in moles, so I write a little n, is equal to the mass of the substance, which we're measuring, which we can just call m, divided by the molar mass, which is a capital M, or put simply, it's just n equals m over. Now, I'm not sure what level of education you guys are at, but you should be okay with just being able to rearrange formula like this. If not, you might be familiar with using a triangle where you just write in, imagine we drew a triangle out of this. Well, m would be on the top, n would be over here, and molar mass would be here. And if you're not already comfortable with this triangle method of rearranging formula, essentially if you just put your hand over, let's say, n, well, you're just left with m over m. So therefore, well, we've got it, n equals m over m. Yeah, little m over mass over molar mass. But let's cover molar mass. So that's the one we're trying to work out. You just cover it, and you're left with n times m. So that's multiply. So you times the amount of moles by the molar mass, and that will give you the mass of the substance. And then, of course, if you then cover molar mass with your hand, if that's the entity you're trying to work out, you're left with m over n. So you're left with mass over moles, and that's how you work out molar mass. Okay, so given everything we talked about in this video, I'd like you guys to pause the video and have a go at these 3 questions, and then we'll go through it together. I've given you the periodic table in the bottom left here too. Okay, so I hope you got on with that okay. Let's check our answers then. So for the first question, we're being asked to calculate the amount of substance in moles in 96 grams of carbon. So what we're trying to work out is the amount of substance, which we know equals m over, so mass over molar mass. So we've got our mass, which is 96 grams, divided by our molar mass of carbon, which we've talked about quite a lot in this video, which we know is just 12. So that's 12. 96 divided by 12, well, that's just 8, isn't it? So that's 8 moles. So there's 8 moles in 96 grams of carbon. Okay, so the next question is asking us to calculate the mass in grams of 0.05 moles of nitrogen dioxide. So rearranging this to work out mass, well, you can do it by the triangle, but you just multiply. Mass is n times the molar mass. So the amount of mole we have is 0.05, and I'll multiply that with the molar mass. So the molar mass of nitrogen dioxide is 14 plus 32, so 46. So that's 2.3 grams. You should plug that into your calculator. So that's the amount of mass in 0.05 mole of nitrogen dioxide. Finally, we're being asked to calculate the molar mass when 2.65 grams contains 0.025 mole of substance. So again, rearranging to make molar mass the subject of our formula. Well, we just divide mass by moles, so that's m over n. The mass we're given is 2.65 grams, and the mole of substance is 0.025, and that works out at 106.0 Remember your units is grams per mole.